In this video, you're learning how to solve the derivative of 1/4 x to the fourth in just a few minutes, and like a ninja. Let's get started. What's up guys, David here. This 1/4 term that's being multiplied by x to the fourth might be causing some confusion for some of you, and I totally get it, because what you may have been used to in learning derivatives is that when you have a function such as x to the fourth, then the derivative is essentially taking the power of x, which is 4, being multiplied by x now raised to a power that's 1 less than what it used to be. So it'd go down to 3. But we don't have f of x equals x to the fourth here. We have f of x equals 1/4 x to the fourth here. So the good news is that you can use a very simple trick to make this problem a lot simpler. Say, for instance, f of x, generally speaking, looks like a constant c, in our case it's 1/4, times some polynomial raised to the nth power. In our case, it's the 4th power. If you want to take the derivative of this function, then you can actually rewrite this in such a way where you pull the constant out. So it would be the same as c times the derivative of whatever your polynomial is. Now, applying this trick to the original problem I gave you, this means that we can rewrite it such that f prime of x equals 1/4, pulling that constant out, times the derivative with respect to x of x to the fourth. Now, looking to the right, you already know that the answer for deriving x to the fourth is simply going to be 4x cubed. And then what happens here, of course, is that the 1/4 and 4 will cancel out, and you get a final answer that is x cubed. And this is a general trick for any polynomial that you're taking the derivative of, and just derivatives in general. You can always pull the constant out. Speaking of x cubed, in case you're learning about integrals or want to get a head start on your AP calculus, you're going to want to check out this video, because I'm going to show you the reverse direction, where if you have x cubed, you can take its integral to find out what the original function f of x was. Hit that subscribe button if you haven't already. Leave a comment and tell me what kind of content you guys like to see, and I'll catch you later.